Hello, welcome to this lecture video. I'm teacher Melai. So what we will do now is to use the same data and also to use data analysis in generating other other mathematical models in time series or the time series forecastings that is used for time series forecasting that can be found in the data analysis in the Microsoft Excel. So to do that, so let us consider again the same data. So this is now our data. Let us place it here. Okay, so what we will do is to go to data, data analysis, and locate, for instance. So we already use moving average. But just to repeat the procedure here, so if we will compute for this, or rather if we will generate that, and then for the output range, so let's place it here. So let's also provide the chart output and the standard error. And so where will we place our analysis? So let us place it here. And then click OK. So this is the result from moving average. So as you can see here, what we included is the data 1, 2, 3. So just to verify this, so let us just move this one more higher. Okay. So just to verify, where did we get this value? So it is the average of the three scores here. So 5.38 plus 3.43 plus 3 divided by 3. And this is the graph. And this is also the standard error. So the computation is the summation of, this is actually the standard error computation. So if you will consider now what is the standard error of this, you can simply use the last number because this is the standard error for the last data. It's 1.616. So this is for the moving average. So if you will predict for the next number, so you just need to use the three previous data and divide it by 3. Add and divide it by 3. Or if we will go back here, so where can we place? So as the, as set in our data analysis, it is, we did not place anything in the interval. So this is where you can place whether you are going to add the 3 previous numbers or the 4 previous numbers or the 5 previous numbers and so on and so forth. So you can indicate it here. So just to show you, so let us do that again. Okay, so let us consider generating it by placing number 4. So data analysis, moving average, click OK. So we already selected the data, place number 4. And then for the out range, so let us place it. Okay, so this is the data set now. So it will include the four data here, 5.38 plus 3.43 plus 3 plus 4.25 divided by 4, it is 4.015. So this is how to compute for our, or to generate our values for moving average. And this is also our equation, our chart. Okay, so aside from that, what else can we do in the Microsoft Excel using data analysis? So let us copy this again. And consider another. Okay, let's move to another data analysis. So what is still useful for coming up with the models? So we have the moving average. So let us see this one by one. Exponential smoothing. So for exponential smoothing also, so just click OK. And then let's place our data set. Dumpling factors. So the usual dumpling factors that we use is less than 1. So sometimes it's 0 0.5, it's 0 0.25. So assuming that it is 0 0.5, so let us place the labels here. Check the chart output and the standard error and click OK. So this is the value for our exponential smoothing. And then next, so this is how to generate exponential smoothing using Microsoft Excel. Let us all again move. So just in case you want to use autoregression, so for autoregression, we are going to move our data. So if we are going to move it here, we will use the same data. So it is like saying that our basis for the next data is itself. Okay, so we will use this, or rather we're going to do the multiple regression model if you still remember how to do that process, except that we will no longer consider, of course, the first data here and the last data because it does not have a corresponding value. Okay, so what we will do is to click data analysis and locate regression. So where is regression? So this is the regression and click OK. So our Y value will correspond to this data. Okay, and X value is of course our values. Our Y value, wait, let me check that. Of course, our Y value is this one. And our X value is this data set. Click and what else do we need? Click OK. Okay, so this is now the first regression. So the R square is 0.41. So the equation here is still Y is equal to mx plus b, but the value of x is x sub n minus 1, which means, or rather Y n minus 1, which correspond to the previous data. So Y is equal to 0.809, for instance, if it's limited into 3 decimal, plus 0.708. So Y sub n minus 1. So it is actually the previous data. And also, you can also do the second autoregression by doing the same procedure in our data set. So where is that data? This one. So we are going to move this again in another data set. But what we can use is only this data. And then follow the procedure again in constructing or inducing regression. So data analysis, and regression. So this is the predicted value, and our values here corresponds to this data, the two data, and click OK. So the value of R squared rather, is higher now. It's 0.6187. So it means that 61.88% of the variance is explained by the model. And that model is using this. The y-intercept is 1.85, and then our x sub 1 is 1.09, x sub is negative 0.61, which means that this again corresponds to y sub n minus 1, and this corresponds to y sub, sorry, y sub n minus 2. So whichever comes first. So let's go back to our data set. So this is our y sub n minus 1, and this data are our y n minus 2. So the second data is the y sub n minus 2. So this is the y sub n minus 2, and this is the y sub n minus 1. So the value of our x, as mentioned, is also the data that is in our data set, but it is auto-regress. So we actually move it by one step, and then by two step if it is a two auto regression. So for the procedure, so we are already provided with the standard error here. You are also provided with R squared. So you can add this in the summary table, wherein in the summary table, you have to present the equation. You have to present what's the R squared and the standard of error for you to check what is the best fit model. Okay, so this is all for this video. Thank you for watching.